Hello, everybody, and good morning. I'm recording this small recording, which I hope is going to be short, to show you a few demonstrations on some of the theory we learned in class. Let me share my screen to show you what my plan is. So my plan is to do with you live in this recording 3 demonstrations. The first demo is on using TMR0 as an event counter. Demo 2 will be about using the microcontroller, the 16F877A, in the sleep mode and making the watchdog timer, configuring the watchdog timer to wake it up every amount of time to do a job and then go back to sleep. Intention here is to save energy. The third demo will be a periodic interrupt where multiple tasks are placed in an interrupt service routine and while keeping the infinite loop empty. So let's start one by one. TMR0 as an event counter. Of course, you remember in class, we use TMR0 to make it count in a speed we configure and overflow every amount of time. And we use this in doing hardware-based delays, periodic interrupts, and so on. Now we're going to use TMR0 as an event counter. So if you remember the structure of how TMR0 clock is configured, we were able to configure TMR0 clock through this TMR0 clock select bit to choose the internal clock over 4, oscillator clock over 4. And this is what we did in all of our demos we did in class. There is another option, is to connect an external clock source to the pin called TMR0 clock pin, which is shared also with port A bit 4. So I can connect a clock source to this pin, or simply I can choose to connect a push button maybe to cause the falling edge or rising edge. So maybe a clock like this with a pull-up resistor, right? So every time when the button is not pressed, the voltage at this clock pin, external clock pin, will be high. When the button is pressed, the voltage will go down. We get a rising edge. When the button is released, we go back to high. So we have a rising edge, press, falling edge, release, rising edge, and this is a clock. So you can count how many. So every time a button is pressed, the counter will increment, the timer will increment, okay? So if we take it without a prescaler, okay, as is, every time we press the button, the timer will increment. We can use a prescaler, of course. A prescaler of 2 will need two pushes. You need to press the button 2 times to get it an increment. So let's do a simple demo real quick on this and see how it's going to work. And the demos I'm going to do today, I'll upload it to e-learning. Okay, so start a new project. Next, let me save it somewhere. New folder, let's call it event TMR0 event counter. Okay. Okay. Event counter. Simply To configure this event counter, we need to choose to use the external clock by setting this bit timer 0 clock select to 1, right, in the option register, right, in the option register, and that's it. So the option register is here. This is the option register. So I need to clock select need to be the external clock. So this has to be a 1. Bit 5 will be 0, 1, 2, 3, 4, 5. This should be a 1. I don't need any pull-ups. External interrupt edge, we don't care about it here. Timer 0 select edge. So select edge will be here a high to low or low to high, whatever. Let's have a 0, for example. Prescaler, we don't want a prescaler. So a prescaler, we don't want to use it. So if you make it a 1, the watchdog timer can use it. So this will be a 1, and keep these prescalers 0 in case you don't want to hurt the watchdog timer. So the option register will be 1010, which is A, and 130 is 8. Okay, so back to our code. Yeah. So first thing, option underscore register will be initially 0xA8. Here what we did is enable, choose the external clock source on pin A4 to trigger timer 0. Okay, that's it. Now every time we're going to push a button or generate a falling edge or a rising edge on port A4, timer 0 will increment. However, to be able to see it, maybe we can display it on on one of our parallel ports that we have connected LEDs to. So maybe port C. So I can say configure port C as output, right? Okay, initialize port C to 0. So all LEDs on port C will be turned off. Now I can say port C equals timer 0. That's it. So port C will always reflect the 8 bits in timer 0. That will not change anywhere here in the software. It will change only by receiving an external clock on port A4. That's it. So let's build this project and program it, put it on the microcontroller, and see what's going to happen. It is programming. Okay. Did it program? Yeah. Maybe I need to. Did I initialize port C? Port C 0. Yeah. Okay. Reset. Something. Timer 0. I didn't initialize timer 0 as well. So let me also have timer 0 start at 0. Yeah. Build. Done. So let me stop sharing the screen, go to How do I stop sharing the screen? Yes, stop sharing. Go to this. Let me share my screen over here. Screen. Okay. Yeah. And let me turn on my camera. Here you go. So this is the board. You see it. You see it. So this is port C, B, and this is port C. Port C is now zeros initially, and it always reflects the status of timer 0. Port A4 is pulled up here, which is going to be this clock source. Whenever I push the button, it will go down. Okay. Now I'll be pushing the button, and it will behave as a clock for port for timer 0. So every time I push, this will start incrementing port C. Okay. So push real quick. Now it's 1, 2. Well, maybe maybe I should do some debouncing or some. But now it's 4, 6, 7, 9. So every time I push, timer 0 keeps incrementing. So after 25 times of pushing, it will become 8 ones. All the LEDs will turn on. Okay. Yeah, keep incrementing. So what changed? What changed the timer 0 is just receiving a clock incrementing by hardware in the background. Okay, so this was the first demo, and as you see, let me stop sharing. Go back here. So all what we did here in the infinite loop, we're just displaying the value of timer 0 on port C, nothing else. We configured the clock of timer 0 to be an external clock. That's it. You know what? I think I'm going to stop this recording and start another recording for the other demo. So this will be part 1. I'll call it part 1. I'll upload this demo to the e-learning. I'll start a new recording in a second. Okay, thank you.